Thank you for nice introduction, and I'm very pleased to share my research experience in Tohoku last few years of Tohoku University, and it's a big chance for me. And today I'll talk about fecal microbiota transplantation and its efficacy for calf diarrhea treatment. So my previous speaker already talked about gut microbiota and metabolites. So my presentation is also the applied version, I think, of their main theme. So let's go to my slide. Fecal microbiota transplantation. I think all of you maybe know about this. It's very popular currently for human study. Fecal microbiota transplantation, basically a medical procedure that transfer healthy feces that you call donor to a recipient suffering from disease, mainly microbial imbalance. And the purpose of FMT is to restore the gut microbiota balance. And FMT can decrease the antibiotic dependency, and obviously it will increase clinical outcome. As I said, in human, FMT is very clinically successful, especially in recurrent Clostridium difficile infection. But in livestock, the uses of FMT is still in early phase. And we are the first in Japan to introduce FMT for calf diarrhea treatment. So why we select calf diarrhea? Because calf diarrhea is a very common enteric disease that causes huge significant economic loss in livestock sector. And calf diarrhea is basically responsible for more than 50% calf death in their pre-weaning stage. And it is a multifactorial disease, and it can occur by bacterial, viral, or protozoa infections, and even some environmental or management practices can also cause this disease. And in calf diarrhea, the gut microbial diversity is reduced, and generally, most often antibiotics are used, but we have some public health concern about overuses or inappropriate uses of antibiotics. So in our FMT study, we have checked the efficacy of FMT at day 1 and after day 7. So the time is very convenient and very easy to check the disease recovery. And this is very alternative to antibiotics. So this is a short view of our FMT research. The last few years, we have conducted several FMT studies based on different aims and scope and different FMT formulations. For example, in stage 1 and stage 2, we have used single donor to single recipient style, and in the same farm style in chip area. And in stage 3, we have used single donor to multi-recipient style in different farms. So today, I will speak much more about stage 3 research, but very short talk about stage 1 and stage 2. Stage 1 that we performed is our first study. We have used fresh feces mediated donor. We have made donor from freshly collected feces. So in that time, we have collected 20 healthy calves as a donor, and their healthy status, the pathogen check by classical pathogen test using some commercial kit. And that classical pathogen test basically check 10 pathogens that are mainly responsible for occurring diarrhea. And in that time, the recipient, we also select 20 recipients, but that calves, they were suffering diarrhea, but they already received antibiotics several times. So we call them intractable diarrhea cases. And the donor feces collection and FMT procedure all are performed on the same day. And in the time, we have achieved 70% efficacy, and obviously 30% we are unsuccessful based on the clinical outcome and the diarrheal condition. So this is the score 1, is the normal feces, this is loose, this is all the healthy. So 3 and 4 basically represents the diarrheal symptoms. So based on this clinical and feces condition, we have determined that our FMT is either successful or unsuccessful. So what happens if FMT is successful, and especially in microbiota or metabolite cases? We have found that in successful and unsuccessful cases, they have different microbiota and metabolite cluster. And the hot factors, what's the donor factor, basically can impact the donor factor for successful or not. So as I said, in the time we have used fresh feces, and at the same day we have performed the experiment, and the donor health status is checked by commercial kit. But when we perform 16S ribosomal RNA amplicon sequencing, we have find out that yes, these two groups are healthy, but they have different microbial compositions. So, and this successful donor and unsuccessful donor, their microbial compositions may impact on the recipient. So, in that time, we have concluded that it's not only the classical pathogen test is important, but we should check further, especially 16S ribosomal RNA sequencing. So this is the end of our first stage study, and we have published this paper in 2022. So if you're interested, please check this paper. And in second stage study, we have introduced innovative FMT. So in first study, we are using a single day experiment, feces collection and FMT procedure at the same day. That's sometimes a little bit tough for the veterinarian doctors because they have to manage lots of cups. So in stage 2, we have majorly focused on making a small scale microbiota bank. So that means we have collected feces at first from the farm, and they send these feces to our laboratory, and in the laboratory we have processed this fecal sample, and we have made the donor. And this donor is ready to use, and anytime when the farm or farmer, they find that they have diarrheal cough, then they ask, and we send this sample to the field. So that was very convenient. And what type of innovative FMT we have made in that time? Mainly in fecal microbiota transplantation. Feces solution directly transfer to the recipient. But in that time, we have isolated the microbiota from the feces, and from using nitrogen's gradient solution, we have isolated the microbiota. And this microbiota is either frozen or is either freeze dry. So these two types of donor FMT we have made. And we also performed FMT, 19 FMT, and the most significant thing is that we have found 100% efficacy using this both FMT and freeze dry FDFMT. However, this technique gives us 100% efficacy, but the microbiota separation and isolation it needs large amount of nitrogens and high-speed centrifuge machine. That means we need much more resource. So this study we are already submitted, and we are fighting to publish this paper, and hopefully I will get some response soon. So now is our third stage research. In this time, we have focused cross-area FMT efficacy, and that we call our major focus is large-scale donor bank. So last stage 1 and stage 2 research we have mainly performed in Chiba area, and the farm is specific. I mean, donor and recipient both were selected from the same farm. But in this time, we have collected 150 fecal sample from 3 areas of Japan, Hokkaido, Chiba, and Okinawa. And from this 150 sample, we have targeted to make 24 best donor. Some other group, they called super donor. But in our group, we term is universal donor. So the best 24 donor we have targeted. And how we select the best donor? In this time, we have select both rainbow Kappa scouts, the commercial kit, and 16S ribosomal RNA polygon sequencing. So how we use 16S ribosomal RNA sequencing for donor selection? Basically, we have a huge data set of diarrhea sample, and this is our collected healthy sample. And using a random forest model, we have select top 10 microbiota. Those are basically linked to diarrheal sample. And using receiver operating characteristics and area under curve, we have made some cutoff value. So this is the overall donor screening and selection. So the donor we have made this type of microbiota, the relative abundance is basically below this cutoff value. So from this we have randomly select from Hokkaido we select 10 donor, and from Chiba we select 9, and from Okinawa we select 5. So total 24 donor we have selected. So this is the microbial compositions of the healthy 150 sample from 3 regions, and as I said, we have select 24 best donor or universal donor. So although they are the best donor, but their microbial compositions is still different. Then then we have think about the core microbiota. So core microbiota is basically those microbiota are highly abundant in all the samples. And we have found these 9 microbiota are highly abundant in all these samples. And study design. So in this time, we have used donor feces, 10 gram per vial. So we make vial and we put 10 gram and we directly freeze dry. In this time, we directly use feces freeze dry, and in the field, basically, they were mixed with 100 milliliter saline and administered to the recipient. And the cups, basically, we have chosen this time, they don't receive antibiotic too much, or at least 7 days before their antibiotic uses or is stopped. And we select 72 recipients from 3 areas, Hokkaido 24, Chiba 24, and Okinawa 24, 72 diarrheal calf, and 24 donor. So every donor is select to 3 areas. So from 24 donor, we performed 72 FMT. So how the efficacy? So we have said we have make 3 types of donor, and we find their efficacy is almost similar, 73.34% to 81.4% maximum for Chiba donor. Chi donor means Chiba donor. And some interesting thing when we find out the intra-area and intra-area efficacy, we find, for example, Hokkaido donor is very effective in Hokkaido itself, but it's not so effective in Okinawa. And Okinawa donor is not so effective in, for example, Hokkaido or Chiba, but they are very 100% efficacy in Okinawa donor. So there is area-specific performance they have. But in overall, they have almost similar type of efficacy. Donor-recipient microbiota compatibility. In FMT study, donor-recipient microbiota matching or compatibility is very, very crucial thing because this matching ensure the donor's microbiota colonization or rejection in the recipient. So this matching is very important, and how they are getting donor microbiota is very important for FMT research. So in our study, we find that all donors are successfully engrafted into the recipients. For example, this is the Hokkaido donor at day 1 and day 7. So at day 1, it's 4% is engrafted, but day 7, it's 11%. And Chiba donor is 7%, and at day 7, it's 15% engrafted their dose. Okinawa donor initially is very low, less than 1%, but after 7 days, it's 6%. The donor microbiota stay in the recipient. Then we have check microbiota and metabolite overall changes. And this the red color is the recipient before FMT, and yellow is after day 1, and green is day 7, and the purple is the donor. And so when if you check closely, you will find that the day 7 recipient and donor is very close. And the same pattern is found on metabolite cases, and day 7 and donor are very close. That means the recipient, after day 7, their microbiota and metabolite are changed and is similar to the donor, and they become healthy. How the commensal type or pathogenic type microbiota changes after FMT from these 3 donors, we have find that day 0, I mean the before FMT, the pathogenic type microbiota is highly abundant in the recipient. But at day 7, the commensal type and the core microbiota that we have checked before, we find that this type of microbiota from donor, they are enriched in the recipient. So we can say that all donors they successfully reduced the pathogenic type microbiota and they enrich commensal type microbiota after FMT. And how about the metabolite changes? And when we check metabolite changes, this side they are upregulated, and the left side they are downregulated. Although Hokkaido donor and Chiba donor, they downregulate many metabolites compared to Okinawa donor. However, if we combine all the downregulated metabolites in a pathway enrichment pathway, if we find that they are mainly the downregulated metabolites are mainly glycine, serine pathway. Sorry, the word is very short. All are mainly basically from amino acid pathway. So that means that after FMT administration, the downregulated metabolites are mainly linked to amino acid metabolic pathway. So what is the significance of our study? So we can say that donors from diverse sources have shown clinical success across various farms in different regions, regardless of the farm practices. So donor from one farm can be used in different farms. So this discussion, how we introduce FMT for calf diarrhea treatment. As I said, we are at the beginning of the FMT for calf diarrhea treatment. We have still to manage the ethical part. We have to manage regulatory affairs. So still we are doing the introductory phase of the FMT research. So as I said, we have performed several types of study with different donor selection and different FMT formulations, and either making donor bank or not, or uses repeated antibiotics or not. So, and we find 70% to 100% efficacy, and it's farm independent and area independent. So if we find out applied how they are, the mechanism of FMT. So in shortly, we can say that the beneficial microbes from donor that we transfer to the recipient, they are basically fight for nutrients for the pathogenic microbiota, and they remove the attachment in the gut. As a result, the harmful bacteria, pathogenic bacteria, their level is going down. And in metabolite cases, maybe FMT boosts amino acid utilizing bacteria, and they lower fecal amino acid metabolites. They also increase short-chain fatty acid metabolites. And they also overall mitigate the metabolic acidosis. That's a very common phenotype of cough diarrhea. And overall, they reduce the cough diarrheal severity. So we can say, yes, FMT presents a very sustainable and natural solution and reduce reliance on antibiotics and for cough diarrhea treatment. So is there any challenge? Yes, we have still some challenges. We have to find out how we can predict FMT success, because FMT is a long procedure and we need lots of resources. So if we can make some prediction model using donor or even recipient before FMT using machine learning or artificial intelligence, that will be excellent. Although we have said something in our first paper how we can predict FMT success, but still we need more research. In this time, we have basically focused on 16S ribosomal RNA sequencing, but in future, if we can check another type of or further microbiome research using shotgun metagenomic sequences, so we will be much more effective, much more successfully predict the efficacy. And we need to understand the donor-related factors and recipient-related factors, obviously, for the best donor-recipient matching. However, procedure-related factors is also important. In our study, we have used single-time FMT. However, if we can, how about repeated FMT? But if we can do what happens, so it's also interesting in future during this time. So this is my overall study, and I am acknowledged about Japan Research Institution and JSP's Kakini. And we also recently we visited Mexico, and we described these findings. And our best slogan is, yes, FMT offers a better cough health. And thank you, everyone.